Hi everyone, in this video I'm going to go over questions 6 through 10. Alright, so problem number 6. The first thing that you would normally do would say, okay, I need to add 1 to the power and then divide by that power. But what you're going to notice is that you have 5x to the 0 over 0, right? When you add -1 to +1, you're going to get 0. So you have to understand that this x to the 0 over 0 is an indeterminate form, meaning we can't divide by 0. That's something that's not allowed. So what you want to do to break up this term instead is write it as 5 times 1 over x, right? Because technically you can bring this negative exponent downstairs and make it positive. So if I wanted to, I can take the antiderivative of 5 times 1 over x. And 1 over x, you should be thinking the derivative of ln is 1 over x. So when I take this antiderivative of 1 over x, the answer is actually 5 ln of x. And then when we take the antiderivative of 4e to the x, that's going to be minus the antiderivative of 4e to the x. And you want to say, okay, the antiderivative of e to the x is e to the x, so it's just minus 4e to the x. And since we have limits, we're going to take this antiderivative from 3 to 5. So this one you can just plug into the calculator. Basically, we're going to plug in the 5 ln of 5 minus 4e to the 5th power. And then 5 ln of 3 minus 4e to the 3rd power. Get those two answers and then subtract them. Now, these answers are not going to be pretty because they are ln's, so I don't expect that you find this answer separate and then this answer separate and then subtract them. Theoretically, you can just go ahead and type this into the calculator to get your final answer. So you'll get negative 510.7563. And any form of this answer was fine. And that's it. The big takeaway from this is that you understand that the antiderivative of x to the -1 is the same thing as saying 1 over x, which is the antiderivative is ln. That's the big takeaway. And also that the antiderivative of e to the x is e to the x, right? That's the takeaway here. All right, let's look at question number 7. All right, so before we can do question number 7, we actually have to distribute this 5x to the 2/3 into both pieces. So remember, the x has a power of 1. So we're multiplying this 5x to the 2/3 times this x. So technically, there's also a coefficient of 1 as well, right out here. So we multiply the coefficients, 5 times 1, which is 5. We keep the base, which is x, and we add the powers. So we're going to add 2/3 plus 1, or 2/3 plus 3/3, which is in fact 5/3. So 5x to the 5/3 minus, and then we're just going to multiply 5x to the 2/3 times -1, which is negative 5x to the 2/3. And we want to take this antiderivative of those things. So again, same thing as we've been doing before, add 1 to the power and then divide by that number or multiply by the reciprocal. So 5/3 is the power plus 1, which is 3/3. That gives you 8/3. So 5x to the 8/3, and then instead of dividing by 8/3, we're going to multiply by the reciprocal. So if we multiply tops with tops, bottoms with bottoms, we get 15 over 8x to the 8/3. Now if we do the second term, we're going to take the exponent, which is 2/3, add 1, which is 3/3, and that'll give you 5/3. So we keep the 5, keep the x, raise it to the 5/3 power, but then multiply by the reciprocal, which is 3/5. These 5s will cancel, and we'll be left with 3x to the 5/3. And don't forget the minus sign between them, and the plus c. That should be your final answer. All right, let's move on to number 8. So number 8 requires us to change those radicals to x to the 1/2. So it's a t, so same thing. So we'll say I want to take the integral of t to the 1/2 plus 2 over t to the 1/2 dt. But what would make this easier is if we took this exponent and brought it upstairs. So to do that, all we have to do is say, okay, integral of t to the 1/2 plus 2, that's now being joined with t to the negative 1/2. And now we can integrate. So again, just like we did before, add 1 to the power. So 1/2 plus 1, 1/2 plus 2/2 is 3/2. So it's t to the 3/2, and multiply by the reciprocal, which is 2/3. Then take this negative 1/2 power, add 1 or add 2/2, and that gives us 1/2. So we'll have t to the 1/2 times the reciprocal, which is 2, times this 2 that's already there. So we get 4. So it's 4t to the 1/2. And then again, don't forget to bring down your plus sign, your 2/3 t to the 3/2. And then because there are no limits, we're going to put a plus c. So that should be our final answer. All right, let's move on to question 9. So for question number 9, we're going to have to change this x, the cube root of x, to say x to the 1/3. So we have the integration from -1 to 4 of x to the 1/3, right? That's the same thing as saying a cube root. And then I'm going to bring this power upstairs. So minus 4x to the now positive 3 dx. So integrate. Add 1 to the power and then divide by that number or multiply by the reciprocal. So 1/3 plus 3/3 is 4/3. So x to the 4/3 multiply by the reciprocal. Minus, take the 3 and add a power, so add it to 4 and divide by that number. These 4's cancel. So we get 3/4 x to the 4/3 minus x to the 4th from -1 to 4. Now again, to do it by hand, you plug in the top number up here minus the bottom number. But for purposes of time, you can just type it into your calculators for now. And your answer should have been -250.9877 ... Okay? Please take a minute to verify these numbers. Pause the video, take out your calculator, see if you're getting the same numbers that I'm getting, and then hit resume when you're ready to continue. Okay, let's look at number 10. So number 10, again, required us to know sine, cos, negative sine, negative cos. So remember, I want the antiderivative, so I'm going backwards. So the antiderivative of negative cos, I look this way, and it's negative sine. So I want to integrate negative cos, and that gives me negative sine of x from negative pi over 6 to pi over 4. So again, top minus bottom. So we're going to do negative sine of pi over 4 minus negative sine of pi over 6. And if you'd like to change it now, that minus minus really will eventually be a plus, okay? So again, just like we did in the problem yesterday, we're going to take the pi over 4 and change it to degrees. So pi over 4 times 180 over pi. The pi's will cancel, and you can divide 180 in 4, and that will give you sine of 45 degrees. Same thing as negative pi over 6, or that should be a negative, sorry. So we're going to do negative pi over 6 times 180 over pi. These cancel, and you'll get negative 30 degrees. So if you look at your exact value charts, sine of 45 is already on there. So that is just negative rad 2 over 2. So that's straight looking at your charts. But when you look at negative 30, you have to do a little quarters are for sodas. So we have to figure out, first we're going to add 360, use coterminal angles. And that if I add 360, I get 330. So with 330, I can do quarters are for sodas. So what quadrant are we in for 330? Well, you should be telling me quadrant 4. How do I find a reference angle in quadrant 3? Quadrant 4. It's 360 minus the angle. So 360 minus 330, which is 30. Put that up there. And what function are we dealing with? Sine. And S stands for SIGN. So what do I know about sine in quadrant 4? So up here, all students take calc. So in quadrant 4, cosine is the only thing that's positive, therefore sine will be negative. So this is negative sine of 30. So if you look at your exact value charts, you're going to see sine of 30 is 1/2. So the answer is just negative 1/2. And then to write your answer nice, negative rad 2 minus 1 all over a common denominator of rad 2. Okay, last but not least was that bonus. I'm actually not going to go through this bonus entirely. It was pretty challenging, so I'm going to just show you the solution. So if you'd like, you could pause the video and try to see if you could work it out. Obviously, nothing like this will be on your final exam, so you don't have to stress about it. But if you're up for the challenge, take a look at the work that I have right now. All right, that's it for today. Please get started on that weekly assignment that you'll see on Google Classroom. It will be due Sunday at 11:59 p.m. Have a good day.